In this video, we're going to look at how to divide radicals. Now, when we have radicals that have the same index, like this, oops. If they have the same index, you can just go ahead and divide what's under each radical and get your answer, simplify from there. So when we're dividing with radicals, the first thing you want to do is divide their coefficients. Then divide what's under the radicals and then simplify your answer. So for instance, on this example here, 12 divided by 2 gives me 6. And then we take what's under the radicals and divide those. So 160 divided by 5 gives me 32. Now again, this works because they are both square roots. Because they are the same radical, we just divide what's underneath them. Now once we do that, we want to go ahead and simplify the answer that we got here, because it's not finished unless it is simplified. So I'm going to take the 32 and break it down into its primes. 32 is 2 times 16, which is 4 times 4, and I'm taking a shortcut here because I've got a pair of 4's here. So I'm going to take this 4 and this 6, multiply them together to get 24, and then I had a 2 left over that stays under the radical. Now let's say that you're working a problem like this and you are not sure if you did it correctly. So what you can do is you can put in your original, so 12 square root of 160 divided by divided by 2 square root of 5, and I typed something in wrong. Oops. 12 square root of 160 divide, oh, that's where I went wrong. And you can get a number. Then if you type in your answer, so I got 33.94 something or other, okay, 24 square root of 2, I got the same decimal. So if you're not sure if you reduced it correctly, you can always put your original in and then put your answer in and see if you get the same decimals. So let's take another look at a problem where it divides evenly, like this one. 36 divides evenly by 9, we get 4. And because they're both fourth roots, we can do 1250 divided by 2. That gives me 625. Now, 625 is a perfect fourth. The fourth root of 625 is 5. So 4 times 5 gives me 20. Now, if you are dealing with variables, remember our exponent rule that says if you have two numbers with the same base and you're dividing, all you have to do is subtract your exponents. The same thing applies here. So 3 minus 2 means I have x to the first power. 9 minus 5 means I have y to the fourth power. Now y to the fourth is a perfect square. Square root of y to the fourth is y squared, and I could not do anything to the x, so that's my answer. Now the next example I've got here looks like it's going to be different, but when you have a problem like this, always look to see if what's underneath will divide evenly, and in this case it will. 48 divided by 16 is 3. And you can't simplify that, so that was the only thing we had to do. Always make sure you double check before you go and try to make the problem more complicated than it is. Sometimes though, it's not going to divide. 40 over 27 does not divide evenly, and you can't reduce it. If it does not divide evenly, what you're going to do is you are going to separate your top and your bottom into two separate radicals, and then simplify each piece. So let's take the cube root of 40 and simplify that first. 40 is 2 times 20, which is 2 times 10, which is 2 times 5. Now I need 3 of a kind because it's a cube root, and I have that. So I can rewrite this as 2 cube root of 5. On the bottom, cube root of 27 is a perfect cube. It's 3. And because 2 over 3 does not reduce, this is my final answer. Similar thing here. 7 over 64 does not reduce. X to the 5th, y to the 6th, that's not going to reduce. So to divide this, we start by separating the top and the bottom into two separate radicals. Now, on the top, I can't simplify the 7, but I can simplify the x to the 5th. Now I'm going to break it up into two radicals here. The 7 I'm not going to be able to do anything with. I'm going to put it here. For x to the 5th, I need my exponent divisible by 5. So I pick a number smaller than 5 divisible by 3, which is just going to give me 3. But I need my total to still add to 5, so I put an x squared here. Now, I did this step on the top. I'm going to go ahead and simplify the bottom a little bit while I'm at it. Cube root of 64 is a perfect cube. So is cube root of y to the 6th. Cube root of 64 is 4. Cube root of y to the 6th is y squared. Now the only thing left I can do at the moment is to simplify this piece. 3 divided by 3 gives me 1, so I just have x. Cube root of 7x squared. On the bottom I have 4y squared, and there's nothing more I can do. 1 over 4 does not simplify. X and y squared, that's not going to do anything. So that's my answer. So when you're dividing these, first look to see if it divides evenly. If it does, it makes your problem much simpler. If it does not divide evenly, separate your top and your bottom into two separate radicals and then simplify each radical. From there, if you can reduce, you'll reduce. Now, the ones I worked just now all ended up with a perfect root on the denominator. But if it does not work out that way, if it ends up like this one where you can't simplify the top or bottom anymore, but you have a radical on the bottom, you're going to have to do something called rationalizing the denominator. Now, if you just have one term, a monomial on the bottom, you're going to multiply the top and the bottom by the radical. So here, the radical is square root of 5. So I'm going to multiply the top and the bottom by square root of 5. Now here's the reason we're doing this. If we take the square root of a number times the square root of the same number, the multiplying rules tell us that we're going to get the square root of x squared, of the number squared, which is just that number. So what that means is if I have something like square root of 2 times square root of 2, I'm just going to get 2. We can use this to make the denominator an integer. So going back to this problem, 3 times the square root of 5. Well, multiplying rules say you multiply your coefficients, so 3 times 1 gives me 3. Multiply your radicals, so there's no radical here, so we just put that here. On the bottom, this one has a coefficient of 1, so 2 times 1 gives me 2. Square root of 5 times square root of 5 is just 5, which means I have 3 square root of 5 over 10. 3 over 10 does not reduce, so this is my final answer. Now this one, same idea. 8 over 15 does not reduce, so we break it up into 2 pieces. I'm going to multiply the top and the bottom by the square root of 15. Now, oh goodness, my brain just froze. 15 times 8 is 120, that was it. We multiply the 8 and the 15 to get square root of 120. Square root of 15 times square root of 15 is just 15. But I'm not done until everything is as simplified as it can be, and I can simplify the top. 120 is 2 times 60, which is 2 times 30, 2 times 15, which is 3 times 5. Now a square root means I need 2 of a kind, and I have that here. So pull out the 2, and my leftovers multiply to be 30, so I put 30 under the radical with 15 on the denominator. 2 over 15 does not reduce, so that's where I stop. Right? So here, same idea. Actually, I'm going to do this one a little bit differently. Not that much differently, just a little bit. If I want to, I can go ahead and simplify the square root of 12. That's 4 times 3, this is 2 times 2. So I can rewrite the top as 6, 3 times 2 gives me 6, square root of 3 over 4 square root of 7. And then multiply the top and bottom by square root of 7. It makes the problem just a little bit easier to work because there's not as much simplifying to do later. So this gives me 6 square root of 21, because 3 times 7 is just 21. On the bottom, I get 4 times 7, square root of 7 and square root of 7, multiplied to be 7, which means I've got 6 square root of 21 over 28. But unlike the others I've been working, 6 and 28, we can reduce that. They're both divisible by 2, so I divide by 2 to get my final answer. So you can always simplify before you start rationalizing. Okay, so for instance here, I can divide my x's here. Get 20 square root of 28 x to the 4th over square root of 3. I can simplify this further. 28 is 2 times 14, which is 2 times 7. And x to the 4th is also a perfect square. So I can write the top as 2x squared square root of 7 over square root of 3. And now that I can't simplify the top or bottom anymore, I can go ahead and multiply top and bottom by square root of 3. So the 2x squared I'm going to bring down, multiply these to get square root of 21, and on the bottom I get 3. And I can't reduce that any further. Now you could have started off by multiplying top and bottom by square root of 3x without simplifying it first. It just means you have to simplify later.
The sophomore baseball game has been canceled for this evening and rescheduled for Saturday. So please do not release the sophomore baseball players at 2:30. The sophomore baseball game has been canceled for this afternoon. Thank you.
Alright, sorry about that interruption. Let's move on. Now, technically, you can simplify this one a little bit ahead of time as well. Okay? Because 8, 2, and 2 are all divisible by 2. That being said, though, I'm not going to do it that way for this problem. I'm going to start by doing it this way. Show you what's going to happen if you don't simplify first, instead you simplify later. It still works out to be the same answer. So I have more than one term on the top, which means I will be distributing the square root of 2. So here I get square root of 16 minus 2 over 2. Well, square root of 16 is 4. When I subtract, I get 2 over 2, which is 1. Now, the next one, again, you can start by simplifying. So I'm going to simplify the 12. That's 4 and 3, which is 2 and 2. So I can write this as 3 square root of 2 plus square root of 6 over 2 square root of 3. And I'm going to multiply the top and bottom by square root of 3. Now, the same deal applies as this one. Because there's two terms on top, I must distribute. This is going to give me 3 square root of 6 plus square root of 18 over 2 times 3, which is 6. If you can simplify, you do. I can simplify the square root of 18. That's 9 times 2. This is 3 times 3. So 3 square root of 6 plus 3 square root of 2 over 6. But I can still simplify. Always make sure you've got it in simplest form. 3, 3, and 6 are all divisible by 3, so I get square root of 2, or square root of 6 plus square root of 2 over 2. But what happens if we have two terms on the bottom? If you have two terms on the bottom, you must multiply by the conjugate of the denominator. So a conjugate is when you have two terms, the same two terms in both values, but the different sign in the middle. So for instance, the conjugate of 4 plus square root of 2 is 4 minus square root of 2. Now on the top, I'm just distributing. So that gives me 16 minus 4 square root of 2. On the denominator, you're going to FOIL or use the box method. So if I multiply these, I'm going to get 16 plus 4 square root of 2 minus 4 square root of 2 minus 2. These cancel out, and 16 minus 2 gives me 14. And because all these numbers are divisible by 2, I can go ahead and simplify a little bit further to get 8 minus 2 square root of 2 over 7. Here, same deal, multiply by the conjugate, so 1 plus 4 square root of 2, and then simplify. So distribute to get square root of 3 plus 4 square root of 6, and on the denominator, let me set this up real quick. There we go. We'll get 1 minus 4 square root of 2 plus 4 square root of 2, and then here negative 4 and positive 4 multiplied to be negative 16. But I also have the square root of 2 times square root of 2, which is 2. So altogether, I get negative 32 when I multiply it together. These cancel out, so I add these together to get negative 31, and I cannot simplify that. So that's my final answer. Alright, I'm only going to do 2 more to show you what to do if we have two terms on both top and bottom. You're still multiplying by the conjugate of the denominator. You don't want to do the conjugate of the top, because it's the bottom we want to come out to be an integer. So 5 and negative square root of 5 on one side, square root of 5 and negative square root of 3 on the other. We get 5 square root of 5, negative 5, negative 5 square root of 3, and positive square root of 15. There are no like terms here. So we're just going to have to write it out. negative 5 plus 5 square root of 5 minus 5 square root of 3 plus square root of 15. There are no like terms. We cannot simplify any of them, so we just leave it like that. And here, square root of 5 and square root of 3 on one side, square root of 5 and negative square root of 3 on the other side. This is going to give me 5 here, square root of 15, negative square root of 15, so these cancel out, and negative 3. When I add these together, I get positive 2. And there's my answer. Here, same idea. You can't multiply by the conjugate of the top because that's going to leave you with a radical on the bottom, and that's what we're trying to avoid. We don't want a square root on the bottom. So we're multiplying by the conjugate of the bottom because anytime you multiply two conjugates together, you will get an integer. So I do the box method for the top. I'm going to get 6 plus 2 square root of 7 plus 6 square root of 7 plus 14, because 2 times the 7 I get will be 14. So combine like terms, 6 and 14 give me 20. Add these together to get 8 square root of 7. Now 8 square root of 7, that can't simplify, so at the moment we're not going to do anything to the top. We might have to reduce later, but we'll see. So 2 and negative 2 square root of 7, and then 2 and positive 2 square root of 7 for the bottom. These multiply to be 4, negative 4 square root of 7, positive 4 square root of 7, and that's negative 4 times 7 to get negative 28. So these cancel out. When I add these together, I get negative 24. And now when I look at these, I can divide everything by 4. So that leaves me with 5 plus 2 square root of 7 over negative 6. Alright, that's it for this video. See you next time.